In this video, we proved the following fact. A palindrome number is a number that reads backwards as forwards. In other words, if you have 72127, if you read it that way, well, you get this back. If you read it the other way, that is, first I write down 7 and then 2 and then 1 and then 2 and then 7. Oh, look at that. I got back the same number. In other words, the first and the last are the same. Let's talk about left and right. The first number on the left is the same as the first number on the right. The second number on from the left is the second number in from the right, and there's a middle number, which can be anything. And what it's saying is that if you have a palindrome number and it has an even number of digits, it will be divisible by 11. And the reason is, say you have 72327. Well, you can add those numbers and you get 7 plus 3 plus 2, and then take away these numbers, which is 2 plus 3 plus 7. That's exactly the same as 7 minus 2 plus 3 minus 3 plus 2 plus 7. I just minus 7. I just collected the numbers that had a plus in front that I'm adding, and I'm collecting the numbers I'm subtracting. I added them up and I denoted I'm subtracting. Don't do this subtraction. Don't do the addition. Why? Because 7 minus 7 is gone, 3 minus 3 is gone, and 2 minus 2 is gone. You get 0. That's the divisibility test for 11. Now, they say it won't work for an odd number of digits. Well, if you have 1, 2, 1, it works because this is 11 squared, and 11 certainly divides 11 squared. But if you have 131, 11 won't go into it. 11 times 1 is 11. You subtract, you get 2. Bring down the 1. 11 goes into 21 one time. 1 times 11 is 11. And when you subtract, you get a non-zero remainder. 11 doesn't go into numbers below 11, so it didn't work. Nobody's saying if you have an odd number of digits that 11 won't divide them. Sorry, if it's an odd number of digit palindrome number, nobody's saying 11 can't divide it. We're just walking away from that one. We're saying it depends upon the number. Some numbers will work, some numbers won't work. But if it's an even number of digits, it will work. Okay. So now, let's note that, well, let's look at an even, well, let's make it palindrome. This is 7 times 1,000, that's that number, plus 2 times 100, that's the 200, plus 2 times 10 to the first, plus 7. This has 1, 2, 3, 4 numbers, 4 digits, but the power is odd. Why is that? Because I shouldn't write 100 here. I'll write 10 squared. Yeah, you have 10 to the first, 10 to the second, 10 to the third, but this doesn't have, I mean, if you want, it's 10 to the 0. Okay, if you have 4 digits, that is gonna be odd. If you have 6 digits, that's gonna be odd. It's always gonna be 1 less than the number of digits. Okay, so we're going to have an odd number of digits. Let the digits or the powers be 2m minus 1, 2m minus 2, 2m minus 3, up to m minus 1, then m plus 1, and then m plus 1, m, then of course m minus 1, all the way down to 3 times 2, or 3, 2, and 1. Now, and 0. There are m digits here. Let's count them. We'll count the digit 0 at the end. That's the first number. Oh, it's a 1 there. How nice. That's the second digit. Oh, there's a 2 there. Third digit. Oh, m minus 1 digits. Oh, let's not forget to add on that first digit, the 0 digit, or the last one. So we have m digits here. Well, from 1 all the way up to 2m minus 1 is 2m minus 1. But then when we add on the 0 digit, we have 2m numbers. Well, if you have 2m numbers, then you have 2m numbers. I have m here. I must have another m here. And the numbers are digits. So m is, well, the halfway mark is here. So these two have to be the same, and the next two, m plus 1 and m minus 2 have to be the same, and eventually 3 and 2 have 2m minus 3 and 2 have to be the same, and those two have to be the same, and those two have to be the same. So let's write this up. Now, if you like mathematical proofs, subscribe to my channel. All we do here are mathematical proofs. So how about we say, let n be a palindrome number with 2m digits. Has 2m digits. So n is equal to a sub 2m minus 1 times 10 to the 2m minus 1 plus a sub 2m minus 2 times 10 to that power, all the way down to, well, about we remove this and let us move this way to the left. Okay, all the way down to, let's say, a sub m plus 1, 10 to the m plus 1 plus a sub m, 10 to the m. And now they start going in reverse order. We kind of have this split here. The 10 to the m minus 1 is going to get that power, plus the 10 to the m minus 2, not that power, that constant coefficient, it's going to get a sub m plus 2, all the way down to 10 to the first. Well, that's going to be that subscript. Need just a little bit more space. Plus a sub 2m minus 2 times 10 plus a sub 2m minus 1. This here is a palindrome number. Okay, so 11 divides n if and only if 11 divides this number minus this number plus that, no, minus, I apologize, plus, now let's see, when we take away an odd number it's plus, when we take away an even number it is, okay. Well, it's gonna go up to, well, let's see. That there is 2m minus m minus 1. Well, I don't know if m is even or not. See, here I can factor out a 2. Okay, so it's plus minus. Plus, well, first is dot, plus minus this number, a sub n plus 1, and then minus plus this number, which is a sub n. You can figure out what the sign is. But then we go back. We add or subtract am. We minus and add back that number, plus 1, etc. All the way down to we add a sub 2n minus 2 and we take away a sub 2n minus 1. We take away a sub 2n minus 1. Minus that plus that gone. Minus this plus that gone. This and this gone. This and that gone. Which implies 11 divides 0, which is true. 11 divides n, if and only if 11 divides this. But it does. It does. This implies 11 divides n. Okay? So, we prove this. Don't get caught up on what those signs should be. Just know if we read the top sign, if that's plus, then the next one should be minus, and the next one should be plus, and then minus. If the bottom one was correct, if that's minus, then it should be plus and minus and plus. And I did carefully live up to that. I would not mark this wrong for a moment. Okay, you don't have to figure out if m plus 1 is positive or not. If you like seeing mathematical proofs like this, subscribe to my channel. See you guys in the next video. Thanks for watching, and don't forget, watch and learn.